Hello everyone, in this video we're going to solve 2025 AP Calculus BC free response questions. Free response question 1. An invasive species of plants appears in a fruit grove at time t equals 0 begin to spread, right? And the function c of t is given by this guy. And c prime of t is given by this one, where t is measured in weeks, right? Now, question A, find the average number from time t equals 0 to times equals 4, right? So you're going to use the average value formula, right? So you just substitute values 1 over 4 minus 0 in the row form 0 to 4. The function c of t is given by this one right here. So you have 7.6. Alright, so you bring up the calculator, hit calculate, and then you're going to hit menu, calculus, numerical interval right here. Right here you hit 0, this one should be 4. Alright, and you hit enter. The answer is 11.1129. Now you need to divide by 4, right? Hit enter. It's going to be 2.778. Now question B. Find the time t when the instantaneous rate of change of c equals the average rate of change of c over the time interval 0 to 4. Alright, so you have average rate of change is going to be c of 4 subtract c of 0 over 4 minus 0, right? So it's going to be multiply by 4 subtract 7.6 tangent of 0.2 multiply by 0 divide by 4, right? So you bring up the calculator and then you're going to hit enter. The answer is 1.28201, right? 38 over 25 plus t squared equals 1.28201, right? Now you're going to bring up the calculator, you're going to grab this one, and you're going to find the intersection, right? 38 over 25 plus s squared. And then you close parentheses, right? Now you hit tab for the second equation. 1.28201. And you hit enter. It's going to be right here. Now remember that the interval from 0 to 4, right? So you need to find the intersection. It should be right here, right? So you need to hit menu, number 6, analyze graph right here, and intersection right here. Move to the left of intersection, hit enter, move to the right, hit enter. So the answer should be 2.154 right here, right? So t equals 2.154 weeks. Alright, let's move on to question C. Assume that the invasive species continues to spread according to the given model for the time t greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Evaluate this limit expression. Alright, so question C very simple. It's going to be limit of c prime t when t approaches infinity. It's going to be limit of the function 38 over 25 plus t squared when t approaches infinity. Now, this is a rational function when the degree on the numerator is less than the degree on the denominator. So, this guy has the horizontal asymptote, y equals 0, right? So when t approaches infinity, this guy approaches the horizontal asymptote, which means 0, right? Now question D. At time t equals 4 weeks, after the invasive species appears in the fruit growth, measures are taken to counter the spread of the species. The function a divided by a of t equals c of t minus this guy. Models the number of acres affected by the species over the time interval t greater than or equal to 4, less than or equal to 36. At what time t for t from 4 to 36 does A attain its maximum values? Justify your answer. So even though you're allowed to use calculator, you need to justify this one, right? So when it comes to maximum, minimum, increasing, decreasing, think about the first derivative, right? So I have AT equals CT right here. I need to take the derivative first, right? So I have a prime of t equals c prime of t minus. Now when you take the derivative of this one, it's going to be 0.1 times natural log of t, right? So alright, now you're going to let a prime of t equals 0 is the same thing as c prime of t minus 0.1 natural log of t equals 0, right? Now c prime of t is going to be given right here, 38 over 25 plus t squared minus 0.1 natural log of t equals 0, right? Now I'm going to add 0.1 times natural log of t both sides, right? So this guy turns out to be... Alright, now I'm going to put this one on the calculator. Alright, the first graph is the blue one, right? The second graph should be 0.1 natural log of t, right? So I need to hit tab. I put 0.1 natural log of s. And I hit enter. So you will see it. The intersection should be right here, right? So I need to hit menu, analyze graph, intersection. Now I move my cursor to the left of intersection, move my cursor to the right of intersection. The answer is 11.44, right? Now I need to calculate A of 11.44, A of 4, and A of 36, right? And I'm going to pick the maximum values, right? So the function A is given by this one right here. So I just rewrite this one over here. Now I need to calculate A of 11.44. So I'm going to bring up the calculator. I hit 7.6 attention of 0.2 times t, but t equal 11.44, right? And then I need to subtract the interval from 4 to t. So I hit menu, calculus, numerical interval. Now I'm going to hit 4 to 11.44. The interval of 0.1. Natural log of s ds. Alright, so I just hit enter. The answer is 7.316, right? 7.316. Now you're going to do exactly the same thing for A of 4 and A of 36. So A of 4 you will get 5.128. And A of 36 you will get 1.743. The final answer must be this guy right here, right? So you need to conclude that at time t equals 11.44 for 4 weeks. 8 obtain the maximum values 7.316 acres. Question 2. Alright. The curve C is defined by the polar equation of theta equals 2 sine square theta for theta between 0 and pi. The curve C and the semicircle are equals 1/2 for theta from 0 to pi, as shown in the figure below. Question A. Find the rate of change of the function with respect to theta at the point on the curve C where theta equals 1.3. Alright, so in order to find the rate of change, you need to take the first derivative, right? So we have theta equals 2 sine square of theta. Then r prime theta equals 2 times 2 sine theta times cosine theta, right? Remember, you need to use the u to the n derivative. It could be n times u to the n minus 1 times u prime, where u equals sine theta, right? Now we're going to simplify this one, so it turns out to be 4 sine theta cosine theta, right? Now we substitute 1.3 for theta into this equation, so we have r prime of 1.3 equals 4 sine 1.3 times cosine 1.3, right? We print up the calculator, hit add calculator, so it's 1.031. Right, question B. Find the error of the regions that lies inside the curve C but outside the graph of the polar equation r equals 1/2. Right, so it's gonna be this guy right here. Alright, now first you need to find the intersection between two polar equations right here. The first one right here and the second one right here, right? So I'm gonna let this guy equals 1/2, right? So I have 2 sine square of theta equals 1/2, right? Now I'm gonna divide both sides by 2, so it could be sine square of theta equals 1/4, right? And then I'm going to take square root both sides, so sine theta equals plus and minus 1/2, right? So you have sine theta equals 1/2 and sine theta equals negative 1/2. For this one, theta equals pi over 6, and this one, theta equals pi over 6, right? That's it, because the domain is within 0 to pi, right? Now the error of the regions is calculated as 1/2, the interval from pi over 6 to 5 pi over 6. The top subtract the bottom, right? The top, which means the curve C right here. So it could be 2 sine square theta square, subtract the bottom, which means 1/2 square, right? D theta. Now we're going to use the calculator to solve this one. We hit menu calculus right here, number 2. And then right here we put pi over 6. Now you hit enter. The answer is 2.0667. Alright, let's move on to question C. it can be shown that ds over d theta equals 4 sine theta cosine square theta minus 2 sine cube theta for the curve C for theta from 0 to pi over 2. Find the values of theta that correspond to the points on the curve C. That is farthest from the y-axis. I just get the x and y coordinate right here. Now suppose there is a point on the curve C which is farthest from the y-axis, so suppose it could be right here, right? So I have the x coordinate right here, or it's right here, right? I have the x coordinate right here should be negative s, right? So if the distance from here to here is farthest, which means the absolute value of s must be maximum, right? In order to do that, you need to find the critical points, right? So we given the derivative of this one right here, right? So we let this one equals 0, right? So I have, I'm going to factor 2 sine theta out. So it turns out to be 2 cosine square theta minus sine square theta equals 0, right? Alright, now we're gonna bring up the calculator to solve this equation. Go to the main screen, right? And you hit graph right here. You input this function, right? Then you can hit enter. It's gonna be right here, right? Now we need to find the intersection. You know that theta from 0 to pi over 2. So you need to limit the domain, right? So I need to hit menu to window and window setting right here. It's gonna be 0, and this one as much right here, pi over 2, right? Pi, which means 3.14 divided by 2, it's gonna be 1.57 something, right? So I put 1.6. Alright, I hit OK. So it's gonna be right here. Now I need to find the 0 of this function, right? So actually the 0 of this function should be right here, right? So I hit menu, analyze graph, 0 right here. Move to the left of 0, move to the right of 0, the answer is right here. 0.955, right? Now we're going to use candidate test, right? So we have theta right here, and this is S R theta. This one actually R cosine theta, right? But R equals 2 sine square theta, right? So it could be 2 sine square theta times cosine theta, right? Now I have 0.955, and the last one should be pi over 2, right? Now what we need to do is to put this function on S mode, right? And then I have it right here. Now I need to calculate f of 0, f of 0.955 and f of pi over 2. So I just hit f of 0 right here. So I have three values right here, 0.769 and 0, right? So I have 0 here, 0.769 and 0. Now I need to answer the question. You need to say the value of theta that corresponds to the point on the curve that is farthest from the y-axis is 0.955. Now let's move on to the next question. Question D. A particle travels along the curve so that d theta over dt equals 15 for all time t. Find the rate at which the particle's distance from the origin changes with respect to times when the particle is at a point where theta equals 1.3. So it means that you need to calculate dr over dt given d theta over dt, right? So question D, we need to calculate dr over dt. Alright, so this one is the same thing as dr over something, right? This one dt. So now I'm going to put d theta over here. Right? It doesn't change, right? Now I have r theta equals 2 sine square theta, right? So I'm going to write it over here. R theta equals 2 sine square theta, right? So I need to calculate dr over d theta. It's going to be 4 sine theta times cosine theta, right? So I just substitute over here. It's going to be 4 sine theta times cosine theta, right? Now d theta over dt is given right here, 15, right? So I'm going to multiply by 15, right? Now I need to calculate dr over d theta, evaluated at theta equals 1.3 equals 4 sine of 1.3 times cosine of 1.3 times 15, right? So I print up the calculator and hit enter. The answer is 15.465, right? Free response question 3. A student starts reading a book at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the student reads is modeled by the differentiable function r, where r of t is measured in words per minute. Selected values of r of t are given in the table below. Question A. Approximate r prime of 1 using the average rate of change of r over the interval 0 to 2. Alright, now you have question A using average rate of change, right? So r prime of 1 equals r1 right here between 0 and 2. So you have r2 minus r0 over 2 minus 0, right? R2 is going to be 100, R0 is going to be 90, right? So you have 100 subtract 90 divided by 2. So it could be 5 words per minute, right? The units right here, words per minute. Now, question B. Must there be a value of C for C between 0 and 10 such that R of C equals 155? Justify your answer. Alright, so this is actually we're going to use intermediate value theorem, which is IVT, right? Now, in order to use IVT, you need to make sure the function is continuous. We look at this one, we see that the function r is differentiable. And then you know that if the function is differentiable, it's going to be continuous. Alright, if the function is continuous, it's not necessarily differentiable. So be careful. So you need to say, since the function r is differentiable, then it is continuous. Now we're going to check r0, r10. R0 equals 90, right? R10 equals 162, right? This guy less than 155 and 155 less than this one, right? But 155 is R of C, right? So you have R of 0 less than R of C less than R of 10, right? So you need to say by the intermediate value theorem, there must be a number C where C from 0 to 10 such that R of C equals 155. Alright, let's move on to question C. Use the trapezoidal sum with the 3 subintervals indicated by the data in the table to approximate the value of this guy. Show the work that leads to your answer. Alright, so 3 subinterval is going to be right here. From here to here, delta S equals 2. From here to here, delta S equals 6. From here to here, delta S equals 2, right? Remember that the trapezoid error formula is given by base 1 plus base 2 times the height divided by 2. Now, from 0 to 2, base 1 is 90, base 2 is 100. The height is 2 right here, right? So you have question C. The error is given by the interval from 0 to 10 r of t dt. It's going to be base 1 equal 90 plus base 2 is going to be 100 times the height, which means delta S equal 2 divided by 2 plus the second one right here. Base 1 is 100, base 2 is 150, the height should be 6, right? So it could be 100 plus 150 times 6 divided by 2. Now plus the third one, 150 plus 162 times 2 divided by 2, right? 150 plus 162 times 2 divided by 2, right? 190 plus 750 plus 312. Then the final answer must be 1252 volts. Now let's move on to question D. A teacher also starts reading at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by the function W divided by this guy, where WT is measured in words per minute. Based on the model, how many words has the teacher read by the end of 10 minutes? Because this is the function of the rate of change, right? So technically, you just integrate this one. D is going to be interval from 0 to 10 of negative 3 over 10 t squared plus 8 t plus 100 dt, right? So it's going to be negative 3 over 10 times t power of 3 over 3 plus 8 t squared over 2 plus 100 t. Evaluated this one from 0 to 10, right? Now you need to simplify this one. 3 and 3 cancel out, right? This is a divided by 2, it's going to be 4 right here, right? So I substitute 10 over here, it's going to be 1000 divided by 10, it's going to be negative 100, right? 10 substitute over here, it's going to be 100. 100 times 4, it could be plus 400, right? And this guy is going to be plus 1000, right? 0 substitute over here is going to be 0. So the answer should be 1300 words. Free response question number 4. Alright, the continuous function f is defined on the closed interval negative 6 to 12. The graph of the function f consisting of 2 semicircles and 1 line segment as shown below. Now, let the function g be the function defined by g of s equals interval from 6 to s f of t dt. Find g prime of a. Give a reason for your answer. Alright, question A, very straightforward, right? You need to calculate g prime of s first, right? G prime of s, so you need to take the derivative of this guy right here, right? It turns out to be f of s, right? Now, g prime of 8 is going to be f of 8, right? Now, f of 8 is going to be right here. So the answer is 1. Now, let's move on to question B. Find all values of s in the open interval negative 6 to 12, at which the graph of g has a point of inflection. Alright, so when it's come to point of inflection, you need to calculate the second derivative, right? So we have g double prime of s is gonna be f prime of s, right? You just take the derivative of this guy right here. Alright, now f prime of s, which means the rate of change of the function f, or the slope of the function f, right? Now, in order for the function g have a point of inflection, g double prime of s must change sign from positive to negative, or negative to positive, right? Now, you look at the graph f prime of s, which means the slope of the function f of s right here. So you need to draw the tangent line, right? So the tangent line is going to be right here and right here, right here and right here, right? And you use the Christmas tree trick. If the lines go in this way, slope is positive. Lines go in this way, slope is negative, right? So this one slope is negative, this one slope is positive, right? So it changes sign as equal -3 right here, right? And the second one is going to be 3 right here, right? Because this is positive and this is negative, right? And the last one is going to be 6 right here, because this one is negative and the slope of this line right here is going to be positive, right? So you have three values, -3, 3, and 6, right? So you have s equals -3, 3, and 6. Now let's move on to question C. Find g of 12 and g of 0. Alright, so we have g of s equal this guy right here. So you have g of 12 is going to be integral from 6 to 12 f of t dt, right? Now since this guy and this guy the same, right? So you just change this one to s, right? So integral from 6 to 12 f of s ds, so that you can use the graph right here, right? Now 6 to 12, which means this region right here. Alright, so this is the right triangle. The area of the right triangle is base times height divided by 2. The base is 6 units. The height is 3, right? So you have 1/2 3 times 6, right? So it could be 9 units, right? Square. Now g of 0 is going to be integral from 6 to 0 f of t dt. So it's going to be negative integral from 0 to 6. You just swap the bound right here and you change the sign, right? So it could be f of s ds, right? So it could be negative. Now from 0 to 6, it's going to be the semicircle right here. Alright, so the area of the semicircle is going to be 1/2 pi r square, right? The radius is 3, right? Because this one is the center. So you have 1/2 times pi times 9, right? So I put it over here. It's going to be -1/2 times pi times 3 square. So it could be -9 pi over 2 square units, right? Now let's move on to question D. Find the value of s at which g attains an absolute minimum on the closed interval -6 to 12. Alright, so when it comes to absolute minimum, maximum, increasing, decreasing, you need to use the first derivative, right? So we have g prime of s equals f of s, right? From the question A. Now, you need to find the critical point, right? In order to find the critical values, this guy right here must be equal 0 or undefined, right? Now, we look at the graph right here, f of s equals 0, it's going to be right here, the first 0 right here, negative 6. The second 0 right here is going to be 6. And the last 0 right here is going to be 6, right? So you have s equals negative 6, 6, and 0. Now you need to find the values of g of negative 6, g of 6, g of 0. And don't forget the interval right here. Negative 6 to 12, right? So you need to check the endpoints. Negative 6, we already have it right here. And the last one, we have g of 12, right? Now, g of negative 6 equals this guy right here. Integral from 6 to negative 6, f of t dt, right? So it's going to be integral from negative 6 to 6, and we need to change the sign right here, f of s ds, right? Again, this guy, the same, we can replace t with s, right? Now, integral from negative 6 to 6 is going to be this guy right here. Now, the net error should be 0, right? Because this one is positive, this one is negative, and they're both the same, right? So when you add them up, it's going to be 0, right? Now, g of 6 is going to be the integral from 6 to 6, f of t dt. So it could be integral from 6 to 6, f of s ds, right? Now, this guy have the same bounds. So the answer must be 0. Remember, you have the formula, the integral from a to a, f of s ds always equals 0. So keep that in mind. Now, g of 0, we got it from question C right here. The answer is negative 9 pi over 2, right? And g of 12, we got it right here, 9, right? Now, we need the absolute value minimum, right? So the answer must be this guy right here, right? So find the value of s. So s must be s equals 0. This is the final answer. Free response question 5. Alright. Let the function y equals f of s be the particular solution to the differential equation dy over ds equals 3 minus s times y squared with initial condition f of 1 equals negative 1. Now question A, find the second derivative of f at the point 1 minus 1, right? Show the work that leads to your answer. Alright, so question A is actually, this is the first derivative, right? Now, second derivative, which means we take the derivative of this one more time, right? So we have d over ds of dy over ds, right? We're going to use the chain rules, right? U times v is going to be u prime v plus v prime u, right? So it's going to be derivative of this one, 3 minus s, could be negative 1, right? Times y squared plus 3 minus s times 2y dy over ds, right? Now, we need to calculate dy over ds, right? So, we have dy over ds when s equals 1, y equals negative 1. We substitute 1, negative 1 into this equation right here to solve for dy ds, right? So it could be 3 minus 1 times negative 1 square, right? So it could be 2. So we have negative 1 times y squared, which means negative 1 square plus 3 minus 1 times 2y, which means 2 times negative 1, right? Times dy over ds, which means 2. Right? Simplify this one, is going to be negative 1 plus this one is equal to, this one equal to, so 4 times negative 2 is going to be negative 8. So the answer is negative 9, right? Now let's move on to question B. Write the second degree Taylor polynomial for f about s equals 1. Now we know that the Taylor polynomial expansion is given by the formula p n of s equals f of c plus f prime of c times s minus c power of 1 over 1 factorial plus f double prime of c times s minus c square over 2 factorial plus etc. plus f n derivative of c s minus c power of n over n factorial, right? Where s equals c is the center. Now in this situation c equals 1 because s equals 1, right? Now we only need to write the second degree Taylor polynomial. So we have p2 of s equals f of c, which means f of 1, right? Plus f prime of 1 times s minus 1 over 1 factorial plus f double prime of 1 times s minus 1 square over 2 factorial, right? Alright, so f of 1 is given right here, negative 1, right? So we have negative 1 plus f prime of 1. We're going to use this one right here. We substitute s equal 1, y equal negative 1 into this one, right? We got it right here, is equal to right here, right? So it could be 2 times s minus 1 divided by 1 factorial equals 1, right? Plus f double prime of 1, we got it right here, equals negative 9, right? So it could be negative 9 over 2 factorial equals 2, right? Times s minus 1 square, right? And this is the answer. Alright, now let's move on to question C. The second degree Taylor polynomial for f about s equals 1 is used to approximate f of 1.1. Given that the absolute value of f triple prime of s less than or equal to 60 for all s in the interval 1 to 1.1. Use the Lagrange error bound to show that this approximation differs from f of 1.1 by at most 0.01. Alright, so question C, we have the error bound formula. It's going to be less than or equal to absolute value of maximum of triple prime of s times s minus 1 q when s between 1 and 1.1 divided by 3 factorial, right? Which means we're going to take the guys right here, f triple prime c times s minus c power of 3 over 3 factorial right here, right? And this guy less than or equal to 60 right here, right? So we have 60 times s right here equals 1.1, right? So it's going to be 1.1 minus 1 power of 3 over 3 factorial. It's going to be 6, right? Now we're going to simplify this one. It's going to be 60 divided by 6. It could be 10, right? So we have 10 times 1.1 subtract 1. It could be 0.1 cube, right? So this guy turns out to be 0.1 square. It could be 0.01. So this one has been proved. Now let's move on to question D. use the Euler method, starting as s equals 1 with two steps of equal sign to approximate f of 1.4. Show the work that leads to your answer. Y over ds is going to be 3 minus s times y squared. So we copy over here. Find f of 1.4, right? Given the starting point is going to be s equals 1 with two step side, right? So we know that the step size from 1 to 1.4 and then two step size, so the step size should be h equals 0.2, right? And you have the formula y sub n plus 1 equals y sub n plus the step size times f prime of s sub n comma y sub n, right? Now you have the initial condition, it's going to be 1, negative 1 right here, right? 1, comma, negative 1, right? Now you scatter table. Now the initial condition 1, negative 1 when n equals 0, right? So this one is 1. This one is negative 1, right? Now when n equals 1, you have the step size 0.2. So this is going to be 1.2. Alright, so we need to calculate this one using the formula right here. y1 equals y0 plus the step size 0.2 times f prime of s0 y0, right? So it's going to be y0 is going to be negative 1, right? Right here. Plus 0.2 times derivative of this one as s equal 1, y equal negative 1. Substitute over here. So you have 3 minus 1 times negative 1 square, right? Now I'm going to simplify this one. It's going to be negative 1 plus 0.2 times 2 times 1, right? So it could be negative 0.6, right? So I have negative 0.6 right here, right? Now n equals 2, so have y2 equals y1 plus the step size 0.2 f prime of s1 comma y1, right? So it's going to be negative 0.6 plus 0.2. Now you substitute s1 y1 into this one right here, right? s1 y1 is going to be right here 1.2 and negative 0.6, right? So it could be times 3 minus 1.2, right? Times negative 0.6 square, right? So I'm going to simplify this one, negative 0.6 plus 3 minus 1.2 is going to be 1.8 times 0.2. So it could be 0.2 times 1.8 times negative 0.6 square. It could be 0.36, right? So y2 right here is negative 0.6 plus 0.2 times 1.8 times 0.36, right? Then s2 right here, which means 1.4, right? So answer should be this guy. Free response question number 6. The Taylor series for a function f about s equals 4 is given by this one and converges to f of s on its interval of conversion. Question A. Using the ratio test to find the interval of convergence of Taylor series for f about s equals 4. Alright, so we have the ratio test, which means limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity is the same thing as limit when n approaches infinity of this guy right here, a sub n plus 1, which means s minus 4 raised to the n plus 2 over n plus 2 times 3 raised to the n plus 1, right? Now divide by a sub n, which means you divide by this one, right? So you're going to multiply by its reciprocal, right? So it could be n plus 1 times 3 to the n over s minus 4 raised to the n plus 1, right? Now we're going to simplify this one. S minus 4 raised to the n plus 2, and this one, it turns out to be s minus 4 left here, right? Now this one right here, 3 raised to the n plus 1, I just write 3 raised to the n times 3, right? So this guy cancel out, right? So I have limit when n approaches infinity of absolute value of s minus 4 over n plus 2 times 3 times n plus 1. Now when n approaches infinity, n much greater than 2, so you just ignore this one, right? This one, same thing, you just ignore 1 right here, right? So you have n on the top and n on the bottom right here, cancel out, right? So you have absolute value of s minus 4 over 3. Now this guy must be less than 1. Alright, so you're going to multiply both sides by 3. So you have absolute value of s minus 4 less than 3, right? It's the same thing as negative 3 less than s minus 4 less than 3, right? Add for 3 sides. So you have 1 less than s less than 7, right? Now we need to check the endpoints, right? Now s equals 1. We have substitute 1 for s into this guy right here. So this guy is the same thing as 1 minus 4 is going to be negative 3, right? Now we can split this guy. So it's going to be the sum of negative 1 raised to the n plus 1 times 3 raised to the n plus 1 over n plus 1 times 3 raised to the n when n goes from 1 to infinity, right? Now we need to simplify 3 raised to the n on the top and bottom, right? So we have the sum of 3 times negative 1 raised to the n plus 1 over n plus 1 when n goes from 1 to infinity. Now we're going to take the limit of this guy when n approaches infinity, right? So limit of 3 over n plus 1 when n approaches infinity. This guy actually 0, right? So by the alternating series test, the series convergent, right? Now we're going to check for s equals 7. So we have summation when n goes from 1 to infinity. 7 subtract 4 is going to be 3, right? So we have 3 raised to the n plus 1 over n plus 1 times 3 raised to the n, right? Now this guy is the same thing as the summation n go from 1 to infinity. 3 raised to the n times 3 over n plus 1 times 3 raised to the n, right? And then we need to simplify this one, right? So it's going to be the sum when n goes from 1 to infinity of 3 over n plus 1, right? Now we take limit of 3 over n plus 1. We compare with 1 over n when n approaches infinity. So it's going to be limit of 3 over n plus 1 multiplied by its reciprocal. So it could be n over 1, right? So it's going to be 3n over n plus 1 limit when n approaches infinity, right? And it's going to be 3, right? Because when n approaches infinity, n much larger than 1, right? So I just ignore this one, right? So you have 3n over n. Now cancel out n. The answer must be 3, right? And you know that 1 over n is divergent by p-series test. So by limit comparison test, the sum when n goes from 1 to infinity of 3 over n plus 1 divergent. Then you're not going to include s equals 7, right? So we're going to combine the condition right here and s equals 1 right here, right? Because it's convergent. So finally, we have the answer 1 less than equal to s less than 7, right? B. Find the first three non-zero terms and the general term of the Taylor series for f prime, the derivative of f about s equals 4, right? So basically, you just take the derivative of this one, right? So we have f prime of s is going to be derivative of this one, bring 2 to the front, right? So we have 2s minus 4 power of 2 minus 1 is going to be 1. So we don't need to write, right? Over 2 times 3, right? Minus, bring 3 to the front, so right, 3 times s minus 4, 3 minus 1 is going to be 2 over 3 times 3 square plus 4 times s minus 4 power of 3, right? Over 4 times 3 cubed, right? And the general term is going to be n plus 1 times s minus 4 right to the n, because n plus 1 subtract 1 is going to be n, right? Over n plus 1 times 3 to the n, right? You just leave the answer like this. You don't need to simplify, right? Now, question C. The Taylor series for f prime described in part B is a geometric series. For all s in the interval of convergence of the Taylor series for f prime, shows that f prime of s equals s minus 4 over 7 minus s, right? So, part C right here, we just took the derivative of the function f is going to be right here, right? So we have f prime of s is going to be the sum of n plus 1 times s minus 4 raised to the n over n plus 1 times 3 raised to the n when n goes from 1 to infinity, right? Now, you need to simplify this guy, right? So it's going to be the sum of s minus 4 raised to the n over 3 raised to the n when n goes from 1 to infinity, right? Now I can combine these two guys right here. So I just write sum when n goes from 1 to infinity, s minus 4 over 3 raised to the n, right? Now if n equals 1, I have s minus 4 over 3 plus n equals 2. Does that mean I have s minus 4 over 3 square, right? N equals 3, s minus 4 over 3 cubed, right? Plus, etc. Plus s minus 4 over 3 raised to the n, right? Now, observe that this one is a geometric series, right? With a common ratio, it's going to be s minus 4 over 3, right? Because you just multiply by s minus 4 over 3 each times, right? Alright, so we have the common ratio r equal this one, right? And the first terms right here, right? Now we have the formula to calculate the sum of infinite geometric series. It's going to be given by the formula a1 over 1 minus r, right? So it's going to be s minus 4 over 3 over 1 minus s minus 4 over 3, right? Now, I need to multiply the top and bottom by 3. So I'm going to simplify 3, right? So it's going to be s minus 4 over 3 right here. I distribute over here. So I have 3 minus s plus 4, right? So it's going to be s minus 4 over 7 minus s. And this is f prime of s, right? Now, let's move on to question D. It's known that the radius of convergence of the Taylor series for f about s equals 4 is the same as the radius of convergence of the Taylor series for f prime about s equals 4. Does the Taylor series for f prime described in part B converge to f prime of s equals s minus 4 over 7 minus s at s equals 8. Now, since the radius of convergence of the Taylor series for f about s equals 4 is the same as the radius of convergence of the Taylor series for f prime about s equals 4. So, s greater than or equal to -1 less than 7, which you found in question A, right? Now, since s equals 8 is outside of this one, right? So it's going to be no. Now, in question C, we just found the common ratio of the infinite geometric series. It's going to be s minus 4 over 3. We got it right here, right? So we substitute 8 right here into this one. So we have r equals 4 over 3, which is greater than 1, right? So it tells us that f prime of 8 equals the sum when n goes from 1 to infinity of 4 over 3 raised to the n is divergent, right? Because r equals 4 over 3 greater than 1, right? Now you need to say the Taylor series for f prime described in part B does not converge to f prime of s equals s minus 4 over 7 minus s at s equals 8. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.